In a single month, 23,019 critical software vulnerabilities were identified and patched across systemically important global infrastructure. This included the code managing municipal water systems and regional power grids. This wasn't the work of human security researchers. It was conducted autonomously by an artificial intelligence. The initiative, known as Project Glasswing, marks a shift in how we secure both critical utilities and the open-source code the world relies on. But there is a contradiction here. Despite this success, the U.S. government is actively forcing Anthropic to pull its newest models, citing national security risks. Anthropic itself is joining that call, urging Congress to implement a brake pedal for systems that are advancing faster than our ability to monitor them. Project Glasswing is so effective at securing the digital world that its underlying intelligence is now considered a liability, raising the question of what exactly makes this tool so dangerous. This map shows the restricted deployment of the Claude Mythos preview. Unlike standard AI releases, this model was strictly walled off to 150 organizations across 15 countries. These include partners like Amazon, Apple, Microsoft, NVIDIA, and CrowdStrike, forming a closed network for defensive research. The model functions as an autonomous defensive agent. It doesn't just suggest code. It actively hunts for zero-day vulnerabilities across every major operating system and web browser. This chart highlights the model's technical proficiency. It achieved a 93.9% on the SWB Bench Verified Coding Benchmark, a metric used to test autonomous software engineering. When deployed against real-world threats, the model maintained a 90.6% true positive rate after triage. That means when the AI flagged a bug in critical infrastructure, it was almost always a genuine vulnerability. These results demonstrate that we can now deploy an autonomous digital immune system capable of outscaling the output of human engineers. However, that same efficiency introduces the dual-use dilemma. This logic tree shows why the risk is so high. The cognitive steps required to find a vulnerability for a patch are identical to the steps required to find a vulnerability for an exploit. The path only changes at the very last step. An autonomous model operating without strict oversight could execute that exploit branch against global targets at machine speed. To counter this, Anthropic is committing $100 million in usage credits, ensuring its partners use the model exclusively for defensive patching and security research. The ability to autonomously mitigate 9 out of 10 critical vulnerabilities carries the exact skill set required to exploit them. This dual capability is why the government and Anthropic are both hesitant to see a general release. To fully understand the stakes, we have to look at the economic timing of this rollout. This demonstration of national security utility happened in the same window Anthropic filed for an IPO, targeting a valuation of over $1 trillion. This illustrates the mechanics of regulatory capture. A company develops unique technology, makes it central to government infrastructure, then lobbies for rules prioritizing it. By warning Congress about AI, while proving their model secures the power grid, Anthropic can write regulations locking out competitors. This is the context for the brake pedal metaphor. Anthropic is calling for safeguards against AI systems that can update and improve themselves during live deployment without any human oversight. Project Glasswing marks the start of a period where the stability of global infrastructure and the success of trillion-dollar corporations will be decided by which autonomous AI can outcalculate the other.